So I believe this part of the code is outdated. In general, there are some golden paths that I am able to maintain, and there are some options that were supported in the past, or I wanted to make sure that the technology choices made it possible to support, like for example the hollow versus not hollow containers. It's obvious that when you want to go deploy the stack like in a production environment, maybe scaling the worker containers and other things, you are gonna need standard non-hollow containers, but I don't have the capacity to maintain all the different combinations of options. So right now what I've settled on is that Apache it listens on port 8877, and in a development setup the Apache really is the gateway to the system. The actual some of the routes that it proxies are generated from Python because while the server name changes, we want the Apache to know the real server name, and the ports could possibly change, and it's also very repetitive, so there is a piece of code somewhere generating these proxy pass declarations right here, generating the dynamic.conf file for all these routes. And what they are all currently just doing is they are proxying to the front end server. But let's go back to the stack declaration. Well, the other task of Apache is serving the job directories. So all that runtime modified job data are stored in the TMP directory. So it works. This is what you get from Apache when you just hit the root. Now we can hit the TMP. There's a couple directories for each job. I will explain this at some point. And we also statically serve the static directory. The static directory is under the sources directory. Sources sources static. Yeah. TMP. I previously used to use Apache for the HTTP authentication. So some of all these, different declarations now be obsolete or unnecessary. There was some work that went into having a useful listing of those TMP files. Anyway, we proxy the rest of the routes to the front end server. The front end server needs a whole lot of environment variables. I don't think it needs the Flask because we're not using Flask here, we're using Fast API. Does the Fast API use the Flask debug variable? Gonna have to look into this later. So don't let this confuse you. The Apache is on port 8877 and the Fast API front end server is on port 7788. Let's go look what's inside the Fast API server. I don't even remember, did we use Flask there previously? We used Django. So front end server. You already see this distinction, or there should be a distinction. Docker scripts directory kind of also serves as a place to store the Docker files, which I believe makes sense because in the sense that Docker image rebuilds when its sources change. The sources for front end might be in the sources directory, but you don't really want to keep the Docker file itself there because changing something in the Docker file shouldn't count as a change of the source codes that are copied or mounted into the they're mounted. It's a whole different story, but anyway, so there is this distinction, and some services don't have any sources here, like Apache. So it just has the directory in Docker scripts. So back to the front end server, it's pretty much this one file here. Mm-hmm. So architecture wise, we include the worker module. So we use Remulate. I don't know how to pronounce it. Remulate. Task processing library, task queue library. So on one end is the front end server. It pushes out tasks. They are stored in RabbitMQ. Through Remulate, and the worker containers grab the tasks and then return the results. And in practice, we import the worker module. Somewhere. We import the worker module, and it has these annotated functions. So annotated as an actor. And when the thing is annotated as an actor, well, there's more to it. We actually have to go and declare the actors. Also declare the actors. And well, we use them somewhere farther down. But the main takeaway is that the worker module gets imported into the front end server, which is it feels weird if you are maybe not used to this exact Python situation. One would expect the client and the worker server to have separate code bases, and it feels dirty to import the whole worker into the front end. But for one thing, it has advantages, or it should have advantages in letting the client, the front end code, type check the calls. And it's just how things are done with, at least with some of these task queues in Python. About the choice of Remulate, I brought in Celery previously, but Celery can make it really hard to debug your code. I'm not the only one who thinks that. There is a video somewhere where you're Python task orchestration. I do this kind of sometimes when I have to make a choice, pick a technology. I do this kind of obsessive search and try to, weigh the pros and cons of a whole bunch of options. But these notes are more, they really put together more topics, more historical issues. But I have some notes about some of the task queue libraries that I have looked into. Some have features that I see as problems, like there's some are designed in a way that jobs or messages could get lost, for example. Remulate is a dramatic fork, right? And Remulate basically has is okay in across a set of features like the reliability, debuggability of the code. It's a small project, but that's a plus point also. With Celery, I mean, I should have, yeah, notes about Celery. Okay, this video for you, if you believe Celery is better, go watch that. You end up with a whole list of, things to do, to configure, to make things debuggable, but in the end it still doesn't work. So yeah, Remulate. I'm happy to, accept pull requests for these nodes, or happy to hear about any improvements to any of the listed libraries. So yeah, the worker is imported from the frontend server. Logging is set up. Sparkle proxy. Yeah, at one point or another, I experimented with allowing access to the triple store that we use, the Allegro graph, through the Python layer for some, to have a unified authentication layer maybe, and to do some data translation juggling. We also experimented with the service that required a particular way to try to access or to post queries, but none of that is currently active. And yeah, like I was saying, the frontend server is a fast API server. Fast API is the new cool thing in Python. Previously, I had employed Django here, but Django is really more of a how to call it? It's a bit of a heavyweight framework. For example, to get a new route working in your application, you have to change about 3 different files, keep all that maintained. Here we have basically a one file REST API web server. Health check. Yeah, health check is a nice one. When you post to the health check endpoint, like well, let me first show you how the whole thing is, but not here. How the whole stack is brought up. Well, I have another a bit older one running on this machine, so health check. I just want to do a curl to the health check. No need to make it so verbose. You get back an OK if you are lucky. And what this does, it runs a request through the, to the worker container, just like when a request is coming from an actual user. With some simple data. So about health checks, we include a message in the health queue. This is because each worker container, like this is the current design that seems to work or make sense. Each worker container spawns 2 processes inside, 2 remote worker processes. Just 1 thread each. Seems to make sense to me because we can do scaling on the level of deploying more containers, and then we don't have to deal with log output being jumbled one over the other in one container. It's not a big deal to spawn 50 containers or whatever. So 2 processes, 1 worker waits exclusively on the health queue. So 1 process is always available to process health check queries. as long as it's not like denial of service attack of health checks. As long as the rate is reasonable, and you can kind of hope and believe that if the actual worker, if the general purpose worker process would exit for any reason, we grab the process ID of it, and we are waiting on its exit. So when it exits, we go and kill the health check worker 2. Yeah, wait for it to die and end the process, and then Docker sees that the container has, the container process has exited and maybe spawns a new one or whatever. Prefetch multiplier is important. You don't want the worker to tell the server that, yeah, I'm gonna process all these 10 jobs, and then each job takes like 1 hour. So prefetch multiplier 1 strictly for after it finishes a job, it always goes talk to the RabbitMQ server to see if there's any more work. So we are on a request as if it was from the client, just the queue is different. And we check that the result is as expected. And if it is, we return the okay that we got here. So the health check is like the way to it's the endpoint to use if you have an external service checking the uptime, the reliability, the availability of your robust server. In general, the robust server, the prolog code contains a couple of different, we usually call them endpoints, unrelated functionalities. Really, there is some, experimentation, a lot of it actually. Some functionalities some code may be shared. Some functionalities may work with common data at some point, but this is what it is. Kind of random stuff thrown in. So the chat endpoint. Let me show you the Prolog code base just a bit. To give you an idea how things flow. The chat route would eventually invoke the code in chat.pl. Chat response, possibly. And we have to like chat state machines, the SBE, I believe. Yep. The small business entity decision logic. And what was the other? It's the SBE. Anyway, there's one more. So there's eventually prolog code being invoked, and the whole, well, yeah, let's look at the process request. Process. I'm gonna have to trace this back to do chat. Yeah. Oh, it's called RPC server. So RPC server is the entry point to the Prolog code base. There's a couple different ways to invoke it from a command line. But somehow there were different designs how the Prolog and Python should communicate, and there are still some ideas for the future, but for one reason or another it's called RPC, and we do the usual. There's a method and parameters in the message. And we either invoke a calculator or we invoke the chat. Chat is the simplest. You see, calling do chat. Where was that? Oh, it's in the RPC server for some reason. Yeah, and the chat endpoint dispatches on either the SBE chat state machine or the residency state machine. So there's residency PL where the residency questions are declared, and there's the SBE where the SBE questions are declared, just a couple of them, and some numbers, some counting logic. So maybe let's move on to the next front end server route. This is invoked from the chat endpoint. I mean route handler. The 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 chat endpoint is the easy one. We an actual client just invokes the robust server with some JSON like we saw in the health check. Okay, I have not done this for a while, but we saw it here or here. So you would actually run a request to the robust server looking something like this. Probably not exactly. This is a bit. This was an old way to do it. We would have to use the chat route, and I suppose state the type here somewhere. Body. Is this already the fast? Yeah, I believe this is a response from the fast API server. That's nice. Although I don't understand it perfectly. Body requires a type member. Like this. Okay, it's thinking. Even for the simple requests, it takes a bit of time to spin up the Prolog process, especially in debugging mode. But yeah, so this is like the simplest kind of request. You send a JSON and you get back a JSON, and that's it. The worker prints out the JSON and exits, and you get it back. It's done. But for the calculator, we start with the upload route. We process the files, or pre-process the files, or even, yeah. Well, so the upload route basically registers a new job with the robust server, a new calculator job. And we don't have we don't use a database for that, but we have the RabbitMQ server storing the jobs in the sense of storing the message for the worker, and at the point where the front-end server stores the message, we know it's on the hard drive there somewhere, and it's gonna get processed sooner or later, and it has a unique ID, and also each job has a directory in the TMP directory on the server. So these UUID like looking names these come directly from the remulate / rabbitmq logic, assigning each message a unique ID. So that's the job, but that's only a part of it. We also ourselves generate these different looking request directories. So that's what's going on here. We create one of these request directories. We save the files, the uploaded files. We don't have a very good story about with regards to submitting a job with containing multiple files. There's some of the functionality in the investment calculator supports